Hi friends, my name is Arun Pandey. I'm a generative AI architect, author, and entrepreneur. In today's session, we'll be understanding the attention mechanism. The content is all coming from Ultimate Generative AI on Google Cloud, my latest book. It all started with the paper Attention is All You Need by Ashish Vaswani. Self-attention mechanisms are much better for contextual understanding. It revolutionized the NLP space because the models can process entire sequences simultaneously. And hence it laid the foundation for models like BERT, GPT, T5, and more. Why was it needed? RNNs and LSTMs, which were the best models at that point in time, they used to process data sequentially, causing slow training and difficulty handling long range dependencies. Self attention allows transformers to handle all the words in a sentence at once, regardless of their distance. And hence, the benefit is parallelized computation, improved performance, and much better efficiency. How does it work? The three basic things about self attention are queries, which are nothing but the focus word, keys, which can be every other words in the sentence, and values, which are the vectors which are used to calculate the weighted sum. What happens, we'll see an example, but what happens is we compute the dot product between query and each key to get a score. We normalize scores with softmax, and then we multiply values by attention weights and sum them to generate the final output. Let's take an example. Our example sentence is the cat sat on the mat with the focus word or query is cat. First of all, each word is converted to a vector or an embedding. We have taken a very simple embedding for all three query key and values, and that's represented on the screen. Now, similarly, the embeddings for keys and values are derived, and in this case, we have assumed these embeddings are also the same. Once we have these, we calculate the attention scores, which is nothing but the dot product of the query value and the key value. For example, the query embedding vector of cat is multiplied with the key value of every other word, and we get again a matrix out of that, a vector out of that, which in this case is 0 1 0 1 0 1. Now we have to normalize this, so we apply softmax. We raise all this to the exponent power, and then we calculate it. We divide it by the total sum. So we get some kind of a ratio in which the grand total is 1. Finally, we compute the weighted sum of all the values. The weighted sum of all these values gives us a probability score, and one word will actually have the highest probability, and LLMs will predict that word as the next word in the sequence. While this is a very simplified example based on the concepts from chapter 1 of my book, Ultimate Generative AI on Google Cloud, if you are truly interested in diving deeper into these topics, I encourage you find out some time and really go through these and enjoy those sessions. For example, in chapter 1, I've also talked about types of transformer architecture in much length with a very detailed example covering each component such as multi-head attention, positional encoding, feed-forward networks and layer normalization, and a case study. So all the best and happy learning. Bye-bye.